So in statistics, there's sort of three big components: collecting information or data, analyzing it, and making inferences or conclusions from it. Okay? We actually did the second one in the first three units, analyzing data. All the different measures we could use for single variable data. That was units 1 and 2. So measures were like mean, median, standard deviation, IQR, range, percentile, Z-score. Okay, we talked about all of those. And then we also talked about two variable data, where we did things like slope, y-intercept, correlation, coefficient of correlation, standard deviation of the residuals, how to find the residual. So all of that was analyzing using certain types of measures. So now we're actually going to go back to the first step, collecting information. And you're going to find this unit basically has no math in it. Okay? Because collecting information, we're going to talk about different things. Okay? We're not really going to do any calculations. So to start with, when we want to know something about a group of people, we identify the group of people as a population. Okay? That populate, and when you think of population, don't just think of like population of a whole country or population of the world. It could be population of BH students. It could be population of BH senior school students. Okay? It all depends on who we want to study or ask questions from. Okay? So a population represents an entire group we want to study. So it could be fairly big or it could be really big. Like if the population, if you decide you want to know something about all the people in a country. So like in Canada, we're looking at almost 40 million people. Okay. If we want to find something about a population and we ask everybody in the population, that's called a census. Okay. When we measure all individuals in a population. Just going to start reading population, POP apostrophe A. Now, depending on what your population is, that could like take a lot of time, take a lot of people to help out, which means it'll likely take a lot of money. Okay. In Canada, there is a time when they do what's called a census. And that's when they find out information about all the people in Canada. Okay? Such as what's your income, what's your highest education level, you know, what else? What's your employment status, things like that. Okay? How many kids do you have? Or how many independents do you have? So you can imagine trying to ask every single person in Canada those questions would take a lot of time and a lot of money, which is why in Canada and most other countries, they only do a census every 10 years because it takes so much time and money. Like we're talking hundreds of millions of dollars for the government to do a census. Okay. So we don't do those too often. Now it depends, again, what our population is. So like if we wanted to, let's say I wanted to know about the preferences of preferences of social media for grade 12 students. I could probably get to every student and ask them, okay? So that way I could do what's called a census. But if, let's say, I wanted to ask all grade 12 students in Winnipeg, that would be really hard to get to. I would need help, okay? I would need a lot of time, and I would probably need a lot of money to pay to get to everybody. Therefore, often we take a sample. Which is part of a population. So let's say I want to know favorite social media platform of grade 12 students in Winnipeg. Instead of just asking all students across the city, which I said is just it'd be a very big undertaking, I take a certain sample. And there's different ways you can take samples, okay, that we'll talk about shortly. When you take a sample, flaws can happen, errors can happen, in which, because remember, if we're going to take a sample of the population, we want that sample to be representative as close to the population as possible. Okay? Like if I just said, okay, I want to know the favorite social media platform of all grade 12 students in Winnipeg, and I only ask grade 12 students at BH. That's not a very good sample. Okay? I would want to ask across the city, because who knows, maybe in different areas of town or something, it's different. Who knows? I don't know unless I do it. So let's look at this example. This is a community college in Tennessee, and their website says our overall graduation placement rate is 98.5%. This means that 98.5% of students who graduated from this college found a job after graduation. Okay. What's the sample? First of all, what's the, maybe I'll say this first. What's the population? Graduates? What's that? I heard community college. Just graduates? What about students that didn't graduate but attended the school? So, I mean, you're right. You could possibly say of graduates, okay? But maybe to get a better representation, we would want to look at all students. Like, what about the students who didn't graduate? Did they find jobs? Okay, wouldn't we want to know that too?
But doesn't it say specifically only for graduates?
What's that?
But it doesn't say that the graduates kind of found jobs after
Non-graduates. Right. Which means that it's probably not representative of the population. Okay. So the sample in this case were people who graduated. You're missing out on a lot of people if you're just focusing on those who graduated. So in that sense, it probably wouldn't be representative, because like I said, wouldn't we want to know, you know, what about those ones that didn't graduate? What was their job placement like? Maybe they Maybe they left 2 years in because they got a job, like a whole bunch of them. Who knows? We don't know unless we include them in the sample. Okay? So, what about students who did graduate? Or what about students who attended, I'll say, but didn't graduate? Another possible misrepresentation might be that, well, the students who graduated obviously showed a lot of commitment. Maybe they had resources that allowed them to graduate, which sort of gives them an advantage in finding a job. Okay. So it could be that too. So it's probably misleading. Okay. Because we didn't include students who attended but didn't graduate. And we could say, you know, what was their job placement rate? Chances are not as high as 98.5%. Okay, because maybe they didn't graduate because they just ran out of money and they could no longer afford to attend, or maybe there was some other circumstance where they couldn't attend school anymore. So that means that the 98.5% is likely an over-representation of the true rate of all students. You're right. I mean, maybe we just want to focus on those that graduate. It is certainly possible. Okay. But let's say we wanted to know about all students, but if we just pick the graduates, okay, that's not a representative sample because likely most graduates would have got jobs, which we can see here, but that wouldn't represent all the students who attended. That number would be too high. So that flaw that results in overstating something or even understating something, that's called bias. Okay? And bias leads to unrepresentative or inaccurate measurements, estimates of the population you're studying. You know, so like, let's say, for example, going back to the social media platform, let's say I decided that I was just going to do BH students, and then some grade 12 BH student invented a new social media platform that everybody loved, right? So then my conclusion would be, 98 or 99% of Winnipeg high school students love this new social platform. But I'm overrepresenting that number because I haven't, maybe other students, other grade 12 students in the city haven't even heard of this stuff, social media. Okay. There are different types of bias. And what happened in here, assuming that we want to know about all students attending the college, not just those that graduated, was something called undercoverage. Okay? And undercoverage happens when part of the population has a reduced chance of being included in the sample. So undercoverage leads to bias. And remember, bias is when you want to say something is overrepresented or underrepresented, or overestimated or underestimated. So that's one type. Okay? Because, and I didn't address this here, but if I look at this, only 27% of students who attended the college graduated. Okay? That's not a big amount. That's a large number of students that I didn't talk to. Okay? Definitely undercovered. Another type of bias is something called non-response, which is kind of self-explanatory. So at a state university in Oklahoma, the university found that 75% of graduates were pursuing another degree or had found full-time employment. The same report showed that the response rate to those questions or survey was only 20%. Okay. That means a big portion did not respond. Why do you think? What are some possible reasons why you wouldn't respond? If, say, you were a student at Rutgers or Rogers State. You saw this survey brought out by the university, and you're one of the 80% that didn't respond. And they're asking you about, are you pursuing another degree or had you found full-time employment? Why might you not want to respond? Okay, personal information, you just don't want to know. That's one possibility. Because what? You don't have a job. And perhaps you're ashamed of answering. Okay. Or you're not pursuing another degree. You're not sure what you're doing. Okay. That's a big portion, which could mean that 75% were pursuing another degree or found full-time employment. Do you think that would be an overestimate or an underestimate? An overestimate, right? Okay. So, non-response, which leads to non-response bias. So when individuals chosen for a sample don't respond, and it leads to a response if these people or individuals differ from the people who actually, or individuals who actually respond. Okay, so just say grads who didn't pursue another degree or a master's or what have you, or I guess, didn't find a job. Maybe 2 too embarrassed to respond. Therefore, that leads to an overestimate of the 70% stated. Like I said, sometimes it might be an underestimate. So in general, when you're talking about sampling bias, and we're going to talk about a few more types, what you want to do when you're writing about it is you want to identify the population in the sample, okay? You want to explain how the sampled individuals might differ from the general population that you're studying. And then you want to explain how this leads to an over or underestimate. Over or underestimate. So before we talk about how we can address bias and reduce it, which obviously is a goal, okay, we're going to talk about a few other types of bias. So if you're asked about it, sometimes you may not remember the term. We've already talked about two, undercoverage and non-response. We're going to talk about a few more. Just talk about, without, you don't necessarily have to use the word. Okay. I mean, if you use the word, great, you know, but if you say, last example, let's say you were asked about it, you know, you would say, well, they didn't ask all students at the university. And so if you didn't state the actual word undercoverage, that's okay, as long as you explain. Okay. Okay. So other types. We talked about undercoverage, we talked about non-response. This is a type, now this next one, it's a type of sampling and it's a type of bias. And it's called convenience. So convenience sampling is when you select a sample that's easy to get to. And convenience bias leads to an overestimate or underestimate because you didn't reach a representative sample. So for example, suppose we want to know how long senior school students at BH spent doing homework last week. We go to the library and ask the first 15 students we see. Okay. This is an example of convenience sampling because they're easy to get to. Okay, I don't have to run around, I just have to stay in one spot and wait for 15 to come. But it's going to be biased. Why? What's that? Okay, so therefore, like if it's usually, so the library is the place that students go to study. So remember, we're asking about the amount of homework they did.
On top of that, yeah, everybody's studying in the library, and you're taking the first 15 to come up to you, and there's only, that's not, compared to how many students are at school. Very that value, it's not really.
Okay, but how would that group of 15 differ?
I mean, if students are using their spares or whatever to go study in the library, then that means they're probably more motivated to do work, or maybe they're studying.
Yes, exactly. Yes, they're probably more motivated students and they're probably getting more work done. than the average student. Because remember, it just says spent doing homework last week. Let's assume you don't necessarily have to do homework away from school. You can do it in school. Okay. So chances are these 15 students are probably, most of them, if not all of them, are highly motivated and therefore doing a lot of homework. Okay. So these students are likely highly motivated and doing a lot of homework. So therefore, the amount of time that these 15 tell you that they spent studying, if you average it out, do you think that would be an overestimate or an underestimate of all senior school students? Overestimate. It's an overestimate. Of amount of time spent doing more. Okay. Yeah. Undercover, well, that's a good point, because sometimes they can overlap. Because you're right, you are missing a group of people, okay? But it's so really, you could say the sampling itself is going to be convenience, the type of sampling. But the bias, you could say convenience bias, or you could actually say undercoverage, okay? That would be good too. So that's another technique. Another, voluntary response. This is when you just send something out and hope that enough people respond. It's up to them whether they want to respond. Okay, so really, the one with the Rogers State University was a voluntary sampling because they had the choice whether they wanted to respond or not. Okay, so voluntary response sampling and bias occurs when the sample is composed of, that right here, volunteers. Who may differ from individuals. So again, that could possibly be undercoverage, right? Because you're missing groups of people. So you want to study heart rate during exercise. You recruit volunteers to run a mile and measure their pulse. Okay. So you want to study heart rate. So that means your population is like your population, I don't know, maybe it could be all adults, or it could be all youth age 15 to 17 or something like that. That's a lot. That's big. Those are big populations, no matter what you choose. What's the potential problem here with the volunteers? Yeah, exactly. I mean, somebody who volunteers to run a mile is probably doing quite a bit of exercise, so they have no problem. Somebody who just sort of does, or does a different type of exercise that they prefer, okay, is like, I'm not running a mile. Forget it. I'm not going to volunteer for that. Yeah. Yes. Yeah. Yeah. So again, that all depends on the population you want to identify, right? Okay. So basically, this type of sampling, okay, volunteers are people who are likely good or very good shape. So would that lead to an over or underestimate of heart rate? Under, right? Because chances are they would have a lower heart rate. Now again, this is not the only issue that you guys have raised. I mean, it's like, well, what's our population? You know, are we looking at certain age groups? You know, are we looking at people who exercise? So it's not, remember, a lot of these things are just not cut and dry, sort of gray areas. Question wording bias. This would probably be pretty, this would be common sense. Let me just look at the example. What show do you prefer? Diners, Driving, and Dives, hosted by the incredibly talented, funny, and interminable mayor of Flavortown, Chef Guy Fieri, or Iron Chef, hosted by the boring Elton Brown? What's wrong? Yeah, you're really favoring Diners, Driving, and Dives by playing up Guy Fieri and then downplaying the other guy. Okay. So the question wording is important too. So clearly, the wording favors Diners, Drive-In, and Dives. That lead to an overestimate of the preference for, yeah. Leads to an overestimate. Of people who prefer, I'll just go to you. Yeah.
So in this question, can you also says that it is to overestimate or
Yes. Yes. Yeah, would lead to an underestimate of those who prefer Iron Chef. Sure. Okay. Should get you guys to break into little groups and then come up with a question and then go try and influence teachers to say the response that you want. Somebody did that to me one time about 6 years ago. I think they were an AP Psych. They asked me what the longest river in the world is. And I said the Nile. And then there are a couple of students saying, are you sure it's not this? Are you sure it's not, I mean, this one, you know, trying to influence me. Anyway. Last one, we'll talk about self-reporting. That's when individuals inaccurately report about their home grades. When completing a survey about lifting weights, I reported being able to bench press 350 pounds. Okay? Yeah, perhaps not. Okay? Right? I mean, obviously I went a ridiculously high amount. but let's say it was something like 200 pounds or something, and in reality, I could only bench press 75. Okay? Which is completely untrue. So that's when people are given the chance to self-report. So people may exaggerate their own abilities. Which likely leads to an overestimate trying to measure. Another example of a study done. I'm not sure who would want to do this study, but anyway, wanted to know what percent of people wash their hands after they went to the washroom. So first thing you ask people about it, chances are you're probably going to get an over or under. Over, because who's going to say, no, I don't wash my hands. But then they actually went into washrooms and then just watched the people to see if they washed their hands, and clearly got a different result. That's all. It's just another example. That's all. So now it's time to let it go. Anyway, that is a sample I would probably never ask you to do. Okay. So how do we get around this? Well, big part of all three components of statistics is probability and chance and randomness. So we get around bias, or we reduce bias, very hard to eliminate bias, by taking a random sample. Okay. Now, be careful with this one. Sometimes there's always a question about this. A simple random sample does not mean every individual has an equal chance of being selected, because you're never surveying individuals. You're never sampling individuals. You're doing groups. Okay, so you want to say that every possible group that you could form in a population has an equal chance of being selected. Every group. That's important. So for example, if I wanted to take a sample of all the students in this class, okay, and let's say the sample size I was going to take was 4. Do you 4 have the same chance of being selected as a group as you 4? Yes. Okay. So it's groups, not individuals. And then there's different ways you can random sample. Obviously, the simple way, and we call it simple random sampling, and you're going to see this a lot, SRS. That stands for simple random sample. So when COVID-19 spread to New York City, the city only provided tests to people who showed symptoms. Some infected people didn't show symptoms. So the sampling method led to an underestimate of the number of people being infected. Instead, they could have randomly sampled the New York City population, tested those who were sampled, and gotten a much better or unbiased estimate of the number of people infected. How would you go about taking a random? Let's say we wanted to sample, how many people are in New York City? I think 10 million or something like that. So let's say we wanted to sample 2,000. Let's say we decided, and we'll talk about sample sizes later, like what's a good size to take. And sometimes bigger is better, sometimes bigger actually doesn't work. Okay. And sometimes everything just gets messed up, like what happened yesterday, right? So many, like this, like statistics, the study or the subject of statistics took a big hit yesterday, big hit, because all these polls were saying certain things, and the opposite happened. Okay? And if you want to know how some people feel about it, go listen to what Jon Stewart said about pollsters, and make sure nobody's in the room. Anyway, so how would you sample 2,000 people? That's good. Any idea?
It says to test.
Yeah, but I want to know just how am I going to select the 2,000? Yes, how am I going to do it randomly? Okay, let's pick a different example. Let's pick 4 of you. Randomly pick 4 of you and ask you something.
Give everyone's number and roll dice.
Give everyone, well, there's no 20, well, I guess there's 27, but I don't think there's a 2,000.
Second dice.
Why must we roll dice? Why must we roll dice? What's that? Yeah, put them in a hat. Spinning, you know, there are easier things than dice and spinning wheels. Like a hat.
Fun. It's entertaining. We're trying to.
And it's time consuming. And perhaps somebody doesn't want to spend that time. Like 2,000 people?
Oh.
How are you going to make a reel? How are you going to make a reel of 10 million people? Like, you need like a train to spin the wheel. Okay. There's random number generators. Go online. Yes, and there's random number generators. Like here. What are you talking about?
That's convenient.
So there, like I want to pick a number from 1 to 10. I want to pick a number from 1 to 2,000. Good question. Okay. We don't include it. We just ignore them. We just ignore it. We just continue on until, you're right. Like we would have to do 2,000 different numbers. So there, 12, 20, 12, 12, 21. It's a palindrome. Anyway. So yeah, so then if I did another 60 and then the 61st one I got 1221, I would just toss it and keep going until I got 2000. Okay. I mean, there are ones you can do this, you can do it on your graphing calculator. You can randomly generate numbers on your graphing calculator. You can randomly generate groups of numbers. Who had the hand?
I have 2 questions. The first question is, like, you could, in this like random number generation, like you can still get a bias.
Possibly, but the chances are lower. Okay, because you did it randomly.
It's even more if you do that.
Charm School?
Princess Charm School.
Princess Charm School. How is that random?
It's more.
Don't boss me. I'm very sensitive.
They do like a poll thing, like It's a charm school, it's gonna be more random. She makes it
Less random. Or more random. More random.
Using a random number generator is not going to be less random than Princess Charm School random.
Do you hear yourself?
Yes, I do. Okay, so let's keep it simple. Number of people from 1 to whatever, let's say we said 2,000. Okay, so assign people a number. No, sorry, that doesn't make sense. That doesn't make sense. You'd have to like number people from like 1 to 10 million.
That's crazy.
Okay.
Do you think you're gonna is Jillian? Yeah.
What's that?
2,000 people.
One at a time.
From 10 million, and then you take from that.
2,000.
Yeah. Like 2,000.
Right. So so you're going to randomly pick a number. Like it's easy. It's easy to do. The numbering the people that go along with it is a little harder. I think so. Population. Let's see.
Why don't you just like on my first? It's not close to percent.
Oh, 8 million. So let's say 8 million.
Yeah, I have another idea. Take them to Hogwarts and have average.
That's also what I'm saying, but then we don't have to line up.
Maybe get.
I like that. Just go into class, find products that are in
Yeah.
your product,
Exactly.
duplicate them, and random around your city.
There you go.
I don't think the first one was yeah, the charge was kind of lying. This is made for when it comes back to such good things like a beeping. Like what's like it's
Anyways. Anyways, yes.
like went door to door or like picked names off the list at random with that random because you're choosing.
Yes.
Okay.
As long as that, I mean, it would be very similar to this. I mean, this is not the only one, right? I mean, like I said, if I wanted to sample 4 of you in this class, I would just take my class list and cut it up 20 names and then put them in a hat, right? Or I could just take the list and just say, okay, alphabetically 1, 2, 3, 4, all the way to 20, use a random number generator. Okay. And then measure those people. Ask them whatever if you're asking them something. So this is sort of how you perform a simple random sample. Okay. And like I said, the next thing we're going to talk about is there's different ways to sample that are not random that we sort of talked about. I'm going to talk about one more. And then there are different ways to randomly sample. Okay, that we'll talk about. I don't know, maybe we'll use a Taylor Swift concert. Anyway, discussion. I want to talk about this one. I like this one. So during World War II, statistician was asked to help the British Air Force decide where to put extra armor on their planes. They gave him charts of the bullet holes in planes that were wounded in fighting, but were able to return. Okay. So here you can see 6 planes. So this is where the red dots are where they were damaged. So this is something, okay, we're not really talking about random or anything like that right now, but we're actually talking about making conclusions. So the conclusion would be, or the question would be, where would you want to put extra armor? In the middle of the plane? How many say in the middle of the plane? The back?
Like in the head, we like on that. The top of the like the front in the middle.
Hang on, hang on.
We put them at the front because there were no holes at the front.
That's what I was saying. Right? Or the-
Yeah, you put it at the nose. You put the extra armor at the nose. You've got to figure that there were some that were hitting the nose and none of them got back,
Oh! I get it, I get it.
right?
You can-
Like three of them or four of them were hitting the tail, the wings, the body. Okay, so that means that if there was armor there, it must have worked because they were able to come back. But none of these had shots in the nose of the plane, front of the plane.
So the question is, we should probably arm the front because now that the plane in back, we can hit the front.
Right. And you've got to figure that planes that went, many of them were probably hitting the nose. Okay, but none of them made it back. So that's where the armor should go. Okay,